we'll jump back in it, although I think I said Michael had the floor last, and he's not back yet. So we'll skip him for now. And do I recall that were we talking about kind of the nature of time?
Yes.
Okay. I'll open with a little data, or at least thinking about time, and then we can go from there. I want to make a claim here, and I'm going to say that change and time are the same thing. I'm going to say they're identical. That is, now, if you're going to say they're identical, and I'm going to say they're identical according to Leibniz's law, that any two things A and B, if they have no properties which differ between them, are in fact the same thing. So that we could call them A and B, but they're in fact A and A. So an example, I might say, this guy is Randy's son. You could say this guy is Seth's father. And even though I've described them by different names there, we're referring to the same object. So Randy's son, with these caveats, is the same as Seth's father, that those are the identical person. We're talking about the same thing. So in the same way, I'm going to say change and time are the same thing. There's that burden, the burden there on me requires that you can propose no property of one thing that is not also the property in the same way of the other thing.
But don't they describe different things? I mean,
my short answer is no, or I wouldn't say they were.
Okay, I mean, but you can, when you're looking at something, you may say because nothing in this thing is changing, therefore time is not progressing. But change is something that you can see, but you don't see. Time describes something different than the change that happens during time.
So when you
the lack of change that happens.
Yeah, when you say you see change, what do you mean by that?
Well, you can, I don't know. You're observing. I mean, your example of looking at two things, and one's for the time freezes and the other action freezes.
So as an example, you might say, like, you can't see digestion. You can see food moving through the...
You can observe it. I mean...
Well, you don't observe the process of digestion as a philosophical construct or as a scientific construct. You observe food moving through the intestine, and you observe it breaking down and enzymes working on it and those kinds of things. But we would say, no, that is observing digestion. So I think you can say the same thing of like, well, if I watch this, I've watched my child grow up. You would say I've watched time pass for my child, or something like that. So
but you'd be describing two different things. One is time passed while my child was growing up. And so
I'm saying that is an artificial construct. And in fact, time is not passing. The time is an artificial construct. And it does not exist as a thing in itself. That whenever we talk about time, what we're really describing is change. In fact, we're describing causal change. That is change based on causality. So that causality, change, that all change occurs, baked into this is all change occurs, in my view, because of causes. So one thing causes an effect. And the cause-effect relationship that is the change is the same thing as time.
So, do you have to say state change? Or is change still...
You don't have to, but that's a good way to talk about it. It's a way that it's in the language now where physics likes to talk about states. Here's this state of matter, here's that state of matter, here's this state of the Hamiltonian, here's that state of the Hamiltonian. So they use that term, so that's as good a term as any.
The second thought would be, since you're rotating, since celestial bodies are moving, there's always a state of change, at least as far as we can predict. So the question would be, if that's true, and if that is equal to change, then it would have to be one. And at least looking at those models, and those states, and those
Yeah, if you were going to freeze time, you mean, or freeze change?
Yeah.
Yes. Yeah, but my point was, the thought experiment was meant to show that whether you froze what you think is time or whether you froze what you think is motion or change from one state to another, that there's no difference between them. And I'm saying I'm not saying that that's a complete argument. That's a thought experiment to help at least bring up the possibility in your mind that these are the same thing. Further, I would turn around. The argument is this: there are no any two objects A and B that have no properties that differ between them are identical. Change and causality, time, causal change, and time have no properties that differ between them. Therefore, they're identical. That's the actual argument, but it's just a thought experiment.
Well, I thought about your, like, one machine freezes time, one machine freezes motion. If there was someone, like, upstairs, like, going on a spirit journey, and, like,
Right.
for the one all the time, he'd be like, oh, I didn't see anything. And then the one, he'd be like, oh, yeah, I was, like, on a spirit journey for, like, a day, while all motion was stopped, but spiritually he had experiences.
So that's why I'm talking about physical time in motion. In this case, to extend it to the metaphysical, I would probably go with state. That he was in this spiritual state, he was in that spiritual state, and there was a change from state 1 to state 2. So if you were going to freeze spiritual motion, in this case, it would be spiritual state change. And then then you'll see that the properties are identical again.
I agree with him. I think that change is something that happens within time, and if you can't interchange the words when you're speaking, then I don't think they can be identical. So for instance, you could say, I hope you change your mind about this.
Yep.
But you couldn't say, I hope you time your mind about this.
Well, what you could
Right?
say
Because they're
is
different.
right. So
There's
it
different
doesn't.
things.
That you also can't say that's okay. Let me counter propose. Do you believe that? So I have a son named Seth. I have a father named Randolph. Okay, so you can't say. Yeah, can I say Randolph's son is going to this class today, and say, well, I'm going to interchange it. Seth's son is going to this class today. Now it's the whole phrase, Randolph's son and Seth's father, right?
Yeah, those are two different ways to reference the same thing, but I don't think you get the same idea when you
Yes.
make that interchangeable, but you don't get any idea when you say, I hope you time your mind.
You do, if you phrase it correctly.
I don't think so. I think there's more going on with the concept of change than
Well,
just time.
Can I give you an example to convince you?
Something is altering.
Can I give you-
So time
can I give you an example?
happen without there being alteration, and especially with something like changing your mind. Can you put it on a temporal line? Sure, but you might not be able to identify a time when it happens. You just know, like, eventually this person's mind was changed because of whatever cause, but you can't pin it down to necessarily a particular time.
So here's a person, and in their head, they think that apples are good, okay? And here's this person later, you would say in time, and they think that apples are bad. Okay, apples are not good. So you would say they've changed their mind, and you would say this happened in time, right?
Yeah, but you just might not be able to identify when exactly.
Sure. Right, but so here's some time t. Here's a time t.
Certainly related to temporality,
Here's time
but
t.
I don't think they're identical.
T2, here's time T1. Okay, so there's some time period in here, or we'll say Tn.
The change has to do with his mind, it has to do with apples.
Yep.
Time doesn't have to do with
Tn.
those things. So there's additional change has to do with his mindset, it has to be embedded with change. Because change is happening to something, it's something that occurs to an object or in a mind, or
It's a difference between two
there's
states.
a lot more, right, there's a lot more to it than time.
So
it does
here's
have
a
additional
state.
properties.
Here's state 1. Here's state 2. And change is the difference between these two states. Okay, change delta S here is what we mean by change. So here's a time. Here's this right here in time. As we say, if you want to say in time, do you think that time is a container? like space? Do you think time is a line? What is time?
It seems to be, according to relativity and Einstein, seems to be, yes, interactive. There's time space. They're not.
Yeah, as an example, Minkowski and space-time is a way of talking about it. But when you talk to the theoreticians deeply on it, they will tell you that neither time nor space exist in Einstein's theory. That this is all, that these are constructs that help us think through them, but they are not themselves existing entities that come into and out of existence. That's most of them, not all of them, so it doesn't mean it's the case. Let's get back to the point, which is, if there's a change between state 1 and state 2, that's all I'm saying is occurring in time. There's a change between T1 and Tn.
Right, it's occurring in time, but it's not time. It's change and time are very interrelated, but they're not the same.
So what's the property difference between the two?
Change has the additional properties of whatever you're talking about. You're talking about apples. You're talking about something occurring in a mind. It brings much more to your ideas of what you're thinking about than just time.
Well, what I'm saying is you can you said if two things are the same thing, you said that we could interchange the words, and that would work. And if you can't interchange the words, then that's an indicator that they're not the same thing.
Right.
So I'm saying that there was a previous state, or there was a state T1 where you thought apples were good. There's a state T2, Tn, where you think apples are bad. I'm glad that those states differ.
But it could be the same amount of time passed, and his mind didn't change.
But my
Something
point
else
is,
changed.
yeah, but that's irrelevant. The point was, I just used non-temporal language to express the difference
Express the difference of what?
between T1 and Tn, between the state where he believes apples are good and the state where he believes apples are bad. And I didn't have to refer to time. I said,
So then the change happened without time?
nope, I think the change in time are the same thing. But the point is, I used no time language that was not temporal in order to express the same thing that you were using temporal language to, which was the indicator you said had to be the case if they were gonna be the same thing.
Yeah, so I don't like giving up words like truth. Truth now can mean opinion.
Right.
I hate the fact. And so I think time and change are two words that are used to describe different things. I agree with you that if there's absolutely no change in state, that's the same as time not passing. But I think they're still describing two different ideas, two different
Concepts.
Yeah, concepts, areas of approaching things. And so I don't like equate. So it's almost like if they're equal, well, then we don't really need both words.
That's correct.
But it's, I think we need both words. I think because they describe different things. Change is an indicator of time passing.
So there's a difference between, I will acknowledge one thing before we hit your second point, which is the important one. Needing both words and both words being useful are two different things. That is to say, if you're talking about a concept, a single concept, then presumably you only need a single word or phrase to describe that concept. But that doesn't mean that you can't use other words or phrases to describe that concept.
In English, we make a point of change.
Right. We will make a point of having 10 different words that refer to the same thing.
Right.
Okay. So you only need one of them, but you could use all of them. So the question is, if you only need, if it's one word or phrase, let's say, if you only need one word or phrase in order to describe a concept, if that's the case, I'm saying that you can use change, causal change, causality change, to, in all of the situations that right now we're like, you need time in order, you need the concept of time in order to describe this. I'm saying you can describe all of the things that we describe using the verbiage of time by only using words describing change.
So, picking on some of the space-time, trying not to go too deep, but is there a disagreement that there is essentially a fourth dimension? That you have three dimensions and then there's at least another dimension? Or another way of describing motion and progression as time?
You'll get confusingly different answers when you ask lots of different people this question, ranging from philosophers to cosmologists to physicists to popularizers of science, etc. So when someone will say something like, well, I'll just leave it at that. Why do you care whether there's a difference of opinion?
Well, I'm trying to figure out if that's not an axiom, that there is a, fourth dimension. I'm trying to understand that there's something where if you look at it, like it seems like Einstein's just saying the observer's perspective is different, but there's still something going on. Newtonian is saying that there's a constant rate, so we're talking about how it passes versus what it is, potentially. And I'm just trying to understand.
Yeah, and I think
there's some sort of common understanding of some foundational thing that is time, or at least the starting point. Because
yes,
it's
and what I'm saying is the foundational thing is change, causal change. That's the foundational thing. We use the language of time because we have found it maybe helpful in the past. But the question is, to the idea of language and description of concepts. Some descriptions of concepts and some language we use with it are helpful in helping us understand the essential thing. Some of the language we use is very unhelpful in that it leads us down the wrong path. So as an example, we think of gravity as an attractive force, right? So we'll say something like gravity pulls something towards you. But that's not strictly correct according to our current theories of gravity. Gravity doesn't pull things. It's not one object pulling things towards each other, right? So if we use that language and we're like, but it does, right? I mean, you put this satellite up and the Earth pulls the satellite towards it and it crashes into it if you don't. And somebody more familiar with general relativity will say, no, the space-time in there is warped and it's following the shortest path. And a path of differential, you could say, but maybe another person will go deeper and say, there's actually a density difference in space-time, and it is moving from a greater density to a lesser density of space-time, or vice versa, depending on whether you think space-time is part of what matter and energy is made up of. So there are a number of ways to do it, but all of them differ significantly in what the essential thing is they refer to. So this is a very important point. If we don't want to confuse ourselves about what the essential thing is, it is very helpful to the human being to not use language that is taking you away from the essential understanding rather than towards the essential understanding. So then how do you determine what language is helping with the essential understanding or not? What I'm saying is go down to the essential thing itself. Build your concept in your mind of what that is as much non-dependent on language as you can. However, whether that's possible or impossible is to using the least that you possibly can. And then build your language up from the concept itself. Not, let's see what tools are laying around linguistically, and we'll randomly pick those in order to describe them. That's going to be less helpful because if those differ in the way that they point in terms of essential reference, then it's random whether you're going to get something that's helpful or maybe unhelpful. Yes, sir.
I think we use time in the also sense of potential for change. Because if you give kids like a test, and it's like, okay, you have an hour, and they run out and they didn't finish it, it's like, oh, I need more time. In essence, I needed more potential for change to happen.
Right. What change specifically did they need to have happen?
Mental states.
Yeah, and there were 10 questions on it, and they changed the paper, and they changed the graphite on the pencil to the point where there were graphite marks. The pencil was this much shorter, and there were graphite marks under question 7. But they had not changed the paper or the graphite under questions 8, 9, and 10, and they want that change to occur. Specifically, preferably, change that the markings indicate correct concepts that the teacher will understand are the right answers to.
But like with the test, or if like 2 kids are running and one is like 10 seconds behind, and it's like, I need to improve.
Is he 10 seconds behind, or is he some distance behind?
Well, once to go a certain distance, one was changed more efficiently within a interval.
Yes, I'm fine. Well, change more efficiently, period. We don't have to say within an interval. Change more efficiently.
It depends on how you measure it.
Aha, yes.
Yeah, if you're looking
And the point is, so
that is this distance between. You're looking at a point in space, And is this time behind?
And when we're talking about physical time, which is mostly what we're talking about here, we've talked about metaphysical mildly or briefly. But when we're talking about physical time, remember what I'm saying about your measurements. All of your measurements are comparative measurements of one physical displacement, one movement compared to another. This person moved from the starting blocks to the finish line when this hand moved from this angle through angle theta to that angle. Or from the tip of the stopwatch, moved from this location to that location. That this corresponded to state 1, and that corresponded to state 2. And that you can do as many interim states as you want between the two of those, between the watch and between the runner. But that you're correlating states there of location, of motion. You're not measuring time. You don't pull up the stopwatch and be like, this is measuring pure time. No, it's not. It's just ticking forward. It's moving. And you compare this movement to that movement. You're just comparing movements. You're comparing change. Yes, sir.
Well,
Sorry, all the way in the back. I accidentally ignored him twice.
Right.
You raised a hand, and I thought it was he, and then I realized no, it was your hand.
I agree that time is useful for discussing change, but I don't know that we need change to discuss time. What if you have a perfect vacuum?
Okay.
There is nothing happening in that. I realize that's theoretical, but
Yep.
still, you look at it at moment X,
Okay.
moment T, and then you look at it at moment T later.
What do you mean T? Like, why is there a T
Later.
in the void?
Later, things
But that's time from your perspective.
right from the outside observer. But
So
in
you're-
that what you're observing, there has been no change.
How do you
The
know-
change is external
How do you know time is moving in this void that you described?
because of our external.
So time in this case is moving for you, but how do you know time is moving in the void? So here, imagine two scenarios. One scenario, you're this outside observer you're talking about, and you're looking into this world, physical world, and stuff's moving around, stars and planets and whatnot. You see change, okay? And let's say you simplify it, and it's just one atom, and it's vibrating back and forth. Okay, there you go. Now you can stop it from moving completely. You freeze time in there, and the atom doesn't move at all. Like if you could, here are the protons, neutrons, and the electron cloud is frozen, or the electron itself is stopped there. And you're like, aha, time is frozen in there. Now you empty the void completely, or empty the thing completely, and now it's a void. And you say, is time moving or is time not moving?
From the perspective of
period.
nothingness in the void, yeah, you're right. There's no, but from an outside observer's perspective, you can assert that time is moving.
No, because you said earlier, well, I think you agreed earlier, that if the atom was completely frozen, time wouldn't be moving in there. It's moving for you on the outside, but that doesn't imply that time is moving for the atom on the inside, right?
Well, atoms have obviously subatomic
Components, let's say the quarks, like as far down, whatever the fundamental particle is, the fundamental particles aren't moving at all. So there's no movement at all. That it's literally frozen. It's
From
time
the
for.
perspective of that frozen atom, you cannot distinguish between time and time n plus one.
I'll ask the question differently. Based on your concept of time, is it possible to freeze time in that little universe?
I don't know.
But you have to know the answer to that in order to answer the question. Because what I'm claiming is that the freezing of motion and the freezing of time are the same thing. Or if they're not the same thing, that they're two different, that the state, the reality of what's going on is if the motion is frozen, then also the time is frozen. But that implies the concept that time can be frozen there and yet still moving for you as an outside observer. This, by the way, is the fundamental failure, in my opinion, in Shoemaker's universe. So Shoemaker is a philosopher that built a universe, a conceptual universe of three parts, A, B, and C. And universe A freezes every 3 years, and universe B freezes every 4 years, and universe C freezes every 5 years. I think that's right. And so in universe 3, like at the end of year 3, it freezes. And so they see universes B and C jump, sectors of the same universe. Sectors of the same universe. They see sectors 4 and 5 apparently kind of jump forward. Like stuff that was here, all of a sudden is over there. And they eventually work out like, oh, time must have frozen for what looks like a year in our sector, and it kept moving in these. And in 4, going to the 5th year, sector B freezes, and so they see the same behavior out of sectors A and C. And then, of course, where the multiples coincide, maybe 2 sectors of the universe are frozen, and they only see 1 jump. And then every 60 years, Shoemaker's question is this: all three sectors of the universe freeze for a year? Or do they? That was the question. And Shoemaker's saying it must be the case that they actually freeze for a year, that even though everything is frozen in there, time can still progresses. Because if not, then the rules must be more complicated. That is to say, they're not simply freezing every 3, 4, and 5 years, but that every 60 years, some other process happens. And I would say to Shoemaker, you are imposing on the outside a viewpoint that says time freezes for a year. How do you know it freezes for a year versus a million years or no, not at all? So what I would say is whenever all sectors of all motion in the universe freezing coincides, time concurrently also freezes / no change occurs because they're the same thing.
And because there's nothing other than this universe. There's no outside observer.
Right. But from the thought experiment perspective, you have to be doing it as an outside observer. Otherwise, there's no way to make sense of it. Yes, sir.
I'd like to use another example because I think that these words that we use, the meaning comes from their use. So if I say, change the sheets tomorrow, because your mother is coming, the change, in that sentence, we're talking about what we're going to do. We're going to take some sheets off, put other sheets on. Tomorrow is the time period in which we want to do that. Those are expressing completely different conceptions. It may be true that in order for us to measure time or in order for there to be time, there have to be some kind of changes, but that doesn't mean that they're identical. The concepts of in those two words are used completely differently.
Yeah, but that's not why I said they were identical. You'll remember I gave a reason for why they're identical.
Right, but I'm giving a reason why they're not identical, because they express different concepts.
But I'm telling you I can express that concept in the same language, in the language of change.
I don't think you can.
I will do so. What you mean by that is the next state when you change from being asleep in bed to the state where you're awake and out of the bed, I want the state of the sheets being on the bed to change from being on the bed to also off the bed.
Right, but you're still using the word change. You can't use the word time there. That change has to do with the sheets. Time is when it's happening, but it's not what is happening.
But the point is, the difference here would be, what is, the fact of change is not the same thing as the thing that is changing, agreed?
I don't know, in this case.
So the fact that the sheet was in
changing.
The fact that the sheet was in the state of being on the bed, and the sheet is now crumpled up on the floor. Okay, those two change. That's a change in state. Those two changes in state.
Right, and then there's another sheet put on the bed.
And there's another one that goes from folded to sticking on the bed. So these are changes in states.
All of that is encompassed in the concept of changing the sheets. We're talking about taking one sheet off, throwing it on the ground, another sheet, unfolding it, and putting it on the bed.
Yep.
All of that. In order for that to happen, you need to understand time, and maybe in order for time to happen, you need to understand that.
You don't. You need to understand causality.
And causality is also temporal.
No, causality does not require any reference to time in order to operate.
I disagree with that.
Well, watch me do it. This right here is make a mess. I'll catch it hopefully before. So this right here is sitting here. I push this way, and this thing changes from being on top of this desk to being in my hand. And it changes because of this push. It doesn't change because of time.
It couldn't happen if there was no time.
It couldn't happen. It couldn't happen if there was no push.
Right, and a push requires time.
That
That
push
push
doesn't.
is happening within time.
I don't have to have time. I don't have to be like, I'll get my container of time out and I'll use it to help me push this thing. I don't. The only thing that's pushing this is my finger.
If time wasn't happening, and your words of change wasn't happening, then you couldn't push it, because pushing it would be a change. So even by your own definition, it has to occur within time.
It
Or
has
it
to-
is time.
It has to
Pushing
change.
it is a change.
It has to change is the point. And the change has to
What
happen.
is time?
The change has to happen because of a previous state. So the previous state has a movement. So here's a state right here where I'm not moving. Here's a state where I'm moving. Which one causes the thing to fall? The non-moving state or the moving state?
The moving state.
So that what is required for this to fall is not time. What's required for this to fall is a moving state.
But you couldn't move if there was no time.
You can move if there's no time. I'm not making any reference to time at all.
Movement is a change.
I'm saying change and time are the same.
So then it is change. It is in time then. By
If-
your definition, that is in time because it is a change.
It is a change. It is not, it is happening, I can say it this way, it's happening in change, not happening in time. Right? What's happening here is what's causing this thing to move. Surely we can agree that what's causing this thing to move is not time. What's causing this thing to move is this pencil pushing on it.
Right, but that pencil couldn't push on it outside of time. It's happening in time.
I'm telling you, time is an artificial construct. That I don't need time in order to explain that this state right here. So consider the following. 2 possible causal states. One causal state is this, right here. No change, at the macro level. The second causal state is this. Okay, and no reference to time at all. Just the difference between just the difference between a state that doesn't move and a state that does move was adequate to explain why this thing changed from the state of not moving to the state of moving. You keep wanting to put it in time, but I'm telling you that we have, for bad reasons, adopted the language of time, when in reality it is not necessary to explain what happened. Fully explain what happened, right? There's nothing missing from my explanation here. That this state occurred because of this state plus this state, right? I take this plus this equals this.
T1 was the first state, T2 was the second state. There was a time that happened.
C1 was the first state, C2 is the second state, C3 is the third state. Full explanation, no reference to time.
Once you have a series of states,
Happens in change.
I don't buy that at all.
You may not buy it, but the point is, did I not explain it without any reference to time?
You may not have referenced it, but the time is still there.
How do you know?
Because we can see you can't move anything outside of time.
You're just making that as an axiom, right?
Movement occurs in time.
Movement occurs as a result of change and
Which is
causality.
time, according to your own definition.
No, I'm saying change and time describe the same thing. So we don't have, I can say it moves in change. If it's the same thing and you're happy with that, then you shouldn't be upset with me saying it occurs in change, because these are exchangeable words.
I don't think they are, but
I know you don't, but I'm giving an explanation that explains why you don't need time. You need to give me an explanation that says you have to have time or it can't go.
So I agree that, let's get this right. Well, time happens in change. I mean, time is you can, where was I going with this? You don't get, here. You can't have change without time. I think it's safe to say you can't have time without change. Doesn't make them the same thing. I think also both a yardstick and the idea of 3 feet indicate the same thing. But one is something you use to measure the, I guess, artificial construct of 3 feet, but they're not the same thing. One is something you use to measure a distance. The other is the idea of the distance. So I think that's how those two may differ, is that change is maybe something we use to measure time happening, and time is just the artificial construct. But I don't think you can say they're equal just because, I mean, in the same way that a yardstick is equal to 3 feet, they're different things. One's used to measure 3 feet, the other is the idea of 3 feet.
So this is perfect. This is perfect. Let me drill down on this for 1 second. You say the yardstick is different than the idea of 3 feet.
It's something we use to measure 3 feet, because 3 feet is the idea of a distance.
Okay, but a yardstick is as an idea of a distance too.
And a yardstick equals
3 feet. All right, so we'll set our yardstick off to the side here. Okay, we've got the idea of a yardstick, and we've got a physical instantiation of the yardstick. And we agree that those are referring to the same thing. my idea of a yardstick, this thing is my idea of a yardstick. It is a yardstick. What is a foot?
It's an idea for distance that someone used there.
But how do I know, like, where do I go to find what a foot is? Like this, is this enough right here? Or is it not my foot?
Bureau of Standards. Or
Okay, so I go truck my way over to the Bureau of Standards and I say, show me a foot. And what would they do?
They probably have an actual.
Okay, so they got some
Metal
ruler
thing.
sitting in a metal case that, at a certain temperature. Or a certain, yeah, right, okay. And they're like, that's a foot right there. I'm like, okay, well, what's 3? 3 is, if 3 feet, they'll just stack them on top of each other. And I'm like, 3 feet, it's a yard. No, what is the idea? 3 of those foot long
Laid
sticks
end to end.
stuck end to end.
Yeah.
So now I'm like, okay, so from the Bureau of Weight and Measures, I make 3 of those things and I stick them end to end, and that's a yardstick. And you would say, yes. And I'd say, okay, but that's 3 separate ones stuck together. This is a single thing stuck together. And you say, well, the idea is that we have made a shortcut, so to speak. We have stuck the measurement distance, the physical distance in our minds, as represented by that reference point right there. We have to go to the Bureau of Weights and Measures in order to compare my foot-long ruler to that foot-long ruler to see if they're the same. Then if I stack 3 of those together, anything we cut at that length is a yardstick. I can cut it out of a piece of spruce, I can cut it out of a piece of metal, etc. But the idea is, it is a physical object that has length of a certain amount, and that's what comprises a yardstick. And usually we'll say, like, it's got to kind of be skinnier rather than, you don't make it it's not a yard cube, it's a yardstick. So generally speaking, it needs to have roughly certain length and width, or width and height, and a certain length, that kind of thing. Okay, so what we've said is, the idea of 3 feet and the idea of the yardstick, both of them refer to a physical thing. There is a physical distance that we use as a reference point. This reference point, this stick right here, I point to that thing and say that's a yardstick, and I point to that thing at the Bureau of Weights and Measures and say that's a foot length. And the only way I get to this is by taking 3 of those and putting them together. Otherwise, this ain't a yardstick, it's just some stick.
But they're referencing an idea of a distance that's been standardized. The distance isn't the thing at the Bureau of Weights and Measures. That's something that represents the 1 foot.
What is at the Bureau of Weights and Measures?
A physical
A
representation.
set of atoms, a set of matter that we agreed
Of an idea of a distance.
that when you move your eyeball, your laser scanner, or you lay your other piece of material on top of it, that when you change from this point and you move to this point, that means you have changed 1 foot in distance.
You don't have to actually change anything.
You do. If you stay right here at this end of the foot stick and you don't change,
I'm just observing.
but you're observing a change. You're observing a difference. You're observing a difference between this and that. And the change that happens in your neurons. Because what you're saying is, I'm thinking of this point right here, and then I'm thinking of all the points in between, and I'm thinking of that point. This series of changes is what happens when you look at a foot stick. Here, watch this. If you only think of these changes, you ignore these changes, and you think about these changes, it's not a foot anymore. That's 2/3 of a foot. In the concept in there is the change from this position to that position. And if you don't have this, by the end of your conceptualizing about this foot ruler, if you don't see the difference between this state and this state, you do not have the concept of a foot.
Pritchett differently announced this question. Does each change in this perspective of time
Yes.
need a cause? And then the second question was, I would say seemingly yes.
Yes.
But the questions that we're asking, does each cause
Entail change.
entail change? If we're using time, could there be, what's the relationship between a cause and a change? Is it a 1-for-1 relationship? How do you avoid an infinite regress?
You have to have a cause for every effect. And the difference between the cause and the effect is a change. Now you can measure that, like you can measure that over, you have to at least delve into the concept probably. We tend to delve into the concept of how many changes occurred between this state and that state. And you can ask the question of between this state and that state, are there an infinite number of potential divisions in there, right? And this is back to the old Greek, or this is, continuum hypothesis kind of idea. How many divisions can you make? How many, and each one of these would be a different state, right? Each one of these is a different state. And depends on how many times you cut it as to how many states there are. You might say it that way.
At least the cause one.
Right, so this state right here is the cause of all of these states, including that one.
And so the question is, there's a finite cause, or that's the question, I think, right?
Yeah, there's a finite regression of causes.
Finite state change that tips off all state changes.
Yeah, and the idea of there being a finite regress of causes is not controversial. Like philosophers broadly agree that you can't traverse an infinite number of things, and if there's an infinite number of temporal intervals in the past, then you would never get to the present. Like that's not a terribly controversial point.
So, but we are talking that there is a necessary cause for a necessary state change that leads to our.
I'm gonna steer away from the word necessary. Can you say, what do you mean by necessary in this case?
Truthfully, I have to replace.
Yeah, I would say necessarily if there is a state 2 and there is a state 1 and they are causally linked, then necessarily one of them is a cause and the other one is an effect.
Well, I guess I exist. I'm a result of changes in states over time. I don't know when.
Well, now we're getting to the real
so the question
ontology
is,
that I wanted to talk about. But let's do the I exist thing. So I exist, and this is a state. I'm living in the state of existence, okay? Some state question mark. So here's the question mark. Was there a previous state that you existed in? Sorry, we'll do the symbology for it, which is weird. It's backwards is exist.
When I did exist. Yes.
So, well, here's a state where you did exist, okay. Well, so then you've gotten to the other question, which is there a state where it's the case I exist is false?
Yeah.
So here's a state S something also. But which way does causality run? Is causality running this way or causality running that way? Which is the cause-effect relationship? Cause-effect relationship's running this way. And if you can go backwards, so to speak, down the cause-effect relationship and you come to a state where you don't exist, then the statement you began to exist would be true.
And then that is, there's other causes, but there's a specific cause for that. But I'm just using that as a basis of I exist, the world exists, the universe exists. Therefore, there must be some cause. And if we're saying it doesn't infinitely regress, there has to be some point.
Yeah, but those 2 points that you just made there of there can't. So originally you said I exist, the universe exists, therefore there must be some cause for it. Not yet. You haven't given reason for that.
Okay.
But if what you say is, furthermore, it's not possible that there be an infinite regress, then yes, that means. But this is the important point. When you look at this universe, yourself in this universe, and you say, well, it's moving around, and I see cause-effect stuff happening. There must be, as you go in the causal direction, the part where the causes are, not where the effects are. They all are causes and effects depending on where you are in that causal chain. But must there be an initial causal point? Yes, there must be an initial causal point. How do you get there? We haven't talked about yet. But let's say that yes, there must be an initial causal point. The question is, can there be is there a terminus to the regression of causation? And the important point on the I exist part is wherever the causal chain terminates, if there are objects like you in this causal chain, that as you go backwards, there was a point in the causal chain where you didn't exist. Then you can't be the reason, you can't be the cause of the other things, of all the other things. Or you can't be the cause of yourself, as an example. So there must be some initial cause, some initial state that is the causal state of all of these things. Now the question is, how do you differentiate the ones that could possibly be that initial cause versus things that couldn't possibly? And the number one thing to do is to say that there's more than one, but the number one thing to do is say, do all of these, is the statement X exists true of every one of these X's all the way back in the causal chain? So as you go backwards in the causal chain, anything that begins to exist, you cut it off as a possibility for being the original cause. And as you work your way all the way back through causality, you will come to a point that is the initial cause for all of these things. Does that initial point itself need a cause? No. Have because there's not a prior causal state in there. Now, the question is the universe that? Is it just infinitely, the universe could have existed in the past and therefore doesn't need a cause? That's where you then go to the next point that you made was temporally, if we want to use that language, I'll say causally, there can't be a causal infinite regress because you've changed it either temporally or causally. That's an infinite number of changes that you have to make, and you cannot transit an infinite number of changes and get to this change where you are right now, which is the broadly agreed upon philosophical point.
I think you can replace like temporal language with change language, but can you replace all talk of change with talk of time? And if you can't, change would be more of a parent to time, in which you could go, like the child of change would inherit its properties, but you can't go up and say replace all talk of change with temporal language.
Well, I'm sort of happy with what you're saying there, because what you're saying is you can talk about change without time, but you can't talk about time without change. And I would say, like, that's my point, is that should suggest to you that change is the fundamental thing. And time is some emergent linguistic tool that we use to help us order our thinking on this one, or maybe hurt us order our thinking.
It would be a subset of change, talking about like agreed reference point of a physical clock that's not accelerating away at the speed of light or something.
I'm not sure I understood that point.
Like when people talk about time, it's normally a reference to like an agreed upon standard physical clock that's not like accelerating such that it's time dilating,
right,
being off from each other.
So are there any clocks in this universe that are not accelerating?
Didn't the one idea of like the edge of the universe itself creates a objective standard?
Yeah, so
synchronization.
What folks realized over change was that, over change in states, was that Einstein's implicate that all time, you can still say time is relative, but that there should be some clock that is a cosmological clock, a universal clock. What would the universal clock would be? And what it would be is any clock that's running that is not moving relative to the expansion of space. So it depends on what you think of the topology of the universe. I think it's fairly clear. All the scientific data suggests that the universe is spherical. And that's because we think that it has expanded out from at one point, backwards if you run it backwards, it's contracting. If you run it forwards in time, it's expanding. And ultimately, we measure space to be flat in terms of three dimensions to 4 dimensions. So we think that it's flat. So if it's flat and it has expanded from a smaller state, then the easiest explanation of the universe is it's spherical. So if you treat it like that, then whatever the center of that expansion point would be your fastest running clock. However, there's another thing to throw in there, is if the presence of matter warps space-time, then if you're near a black hole, it's ticking more slowly. So what I would say is there is at least one point in the universe where it is most distant from all gravitational effects and where it is not in motion relative to the expansion of space. That's the fastest running clock in the universe. The slowest running clock in the universe is the one that's been in the greatest mass density. You can imagine like a black hole that forms first. That's the slowest running clock in the universe. And that those provide bounds on the lowest and highest value of how much time or change has occurred.
So
Yes, I'm sorry.
why is change itself happening faster or slower in different parts of the universe?
That has to do with how fundamental physical laws operate. So if the idea there is something, I think the idea lies in the density of mass energy. The greater the density of mass energy, the more, like basically from, not the same concept, but like think of a concept like momentum. Or think of this, an easier one is this. You're walking through a fluid right now. When you get up and walk, you're walking through air. When you walk through a more dense fluid, water, everything slows down, right? And you walk back out of the dense fluid, you speed up again. Same concept. The question is whether mass energy density works like that as well, and I think the answer is yes.
Sound speeds up in water. Anyway,
But why?
denser collation of atoms.
But I mean, what causes sound to move faster?
I think it's just the propagation of, you have tighter collection of atoms, so.
Right.
You know,
So when you actually look at the individual movements that are happening, the gas molecule versus this,
Right.
the transmission, the movement of the molecules is the secret.
Right, that's not a question.
Oh, right.
To that point, can you have a metaphysical time before space-time?
If you have changes in state.
Right. I'm thinking of this, I like this Tolkienian idea of the creation of the universe, kind of like how he says in the Silmarillion, how, God spoke to the angel, but the angels were all singing, and one angel sang a discordant melody, and God was essentially like, hey,
Knock it off. Yeah.
knock it off. Let me show you what you've done. We'll act this out in creation. And then he created Middle Earth.
Right.
Could not something similar happen with us, where God changed states in some sort of metaphysical place, created minds, and then created space-time for these minds to occupy?
So in what, let's, using just the language of time, let's stick with time for now, that you will say that in this Tolkien myth, you've got singing going on, right? And so at a minimum, you're changing pitch as you move from one note to another, or the notes differ. Yeah, so you're in a metaphysical time there, right? Right. And you're in time because you're in state changes. Now, what I'll say is, why are we bothering to bring time into this? Let's just talk state changes, because that's all you need.
Well, I think people, the question, so part of me says, I agree with you entirely on the whole time exchange. Actually, you sold me on that one. But there's just a really big delta between state of universe not existing and state of existing, with all the potential theological implications of that. Like, did the fall happen before, creation? Or did it happen, after creation? We don't know. So, I guess, was there a time when God was sitting there thinking to himself before he decided to create the universe?
So there was a state where God, in my theology, there's a state where God exists prior to the existence of the universe, which means that in the cause-effect relationship, he's the cause, universe is the effect. The question is, when God's in this initial state, is he thinking? So when we say thinking, what do we mean? I'm thinking about blah. What do we mean I'm thinking about it?
We're figuring things out. We're proceeding forward. We don't know the future.
But give me an example of, talk me through thinking about something. Describe it to me.
Yikes. I don't know. Yeah,
Not neurologically, just conceptually. Not like this neuron fires and that neuron fires, but like, what do you mean you're thinking through something? Give me an example of something that you think through and tell me what you mean.
the shirt I picked out this morning.
Okay, so what happened?
I looked in there, I thought I haven't worn this one for a while because it's over here in the closet.
Yeah.
I pulled it out, I put it on, I buttoned up the button, and I looked at it, it looked like it had little stains on it from something. Anyway, it's I thought, well, I don't want to go there. I mean, pick something else out. Wrinkled, but.
All right, so here you are. You're in the initial state is that you have in your mind a question: what am I going to wear today? And then you proceed to the next state, further down the causal chain, is because I'm wondering about what I should wear today, I then choose to walk into my closet. Because I chose to walk into my closet, and the cause for me walking into my closet was wanting to wear something today, is I now observe the shirts. Now, because I observed the shirts with this causal chain, so I didn't just observe the shirts in a vacuum. I observed the shirts because of the causal chain. I wondered what to wear today. I went to where I know that there are things to wear. I observed the shirts. So these are clear causes of this thing. This didn't randomly happen. And then you pick one because it's on this side, not that side, because of the reasons that you said. Then you reject it because of the reasons you said. But each of these are causal states that lie prior. So your thinking about thing represents a series of state changes, mental state changes. Metaphysical state changes if you believe that the mind is not physical. If you believe the mind is physical, then they're just physical state changes. But they're still state changes, and they're causally linked. And that's what we mean by a thought. Don't have to talk about time. I can talk strictly in the language of causality and state change and get way more than I get out of time. Because if I say this happened in time and then that happened in time, one of my questions is, what's the linkage between the two? And then you have to go further. You have to delve back into why the state changes include a causal relationship. You don't have to do that if you're talking state changes and causality. You do have to do it if you're doing time. That's why time is not fundamental. Time is a second or third or fourth emergent property. The description, I would say, not even a property, but a description of what is actually happening in a causal chain.
Say, like, I want to write a book, and I take a spaceship to where time is fastest in the universe.
Okay.
And I come back next week, and like I've written the whole book.
Yeah.
And it's like, oh, why didn't you write a book in the last week? And it's like, oh, it's not fair because you had more state changes where you went.
Yes.
Did that imply that that person had more states?
Well, it came at a cost. What's the cost?
Well, they're older.
Yeah, you got older, right? And the other guy's younger than you.
Did they have more states? And that in every state they could look back and like that person was frozen in that state? Or did they end up getting more states from?
So we got to talk a little bit about rate here. So how frequently you're comparing changes. Okay, so if you're going to compare changes every 5 wiggles of an atom versus every 5 billion wiggles of an atom, that matters. But if we agree that I'm going to compare it every 5 wiggles of an atom in an atomic clock that I'm holding, then as I look at 5 billion wiggles of an atom, I watched myself go through 5 billion state changes. When I look at his atomic clock, while my atomic clock wiggled 5 billion times, his wiggled 3 billion times. And so now you know what the difference was. This one wiggled 5 billion times, that one wiggled 3 billion times. I had that much more state changes, opportunities, than he did. And this is the whole light clock thing where Einstein's talking about 2 observers, one on train, one, and they don't necessarily agree. Special relativity makes a mistake in that thought experiment. So you actually can tell whose clock was right, so to speak. So imagine the Einsteinian a version of his thought experiment where there's an observer sitting there on the train platform and an observer on the train. And the train goes blasting through the station at some high speed relative to the speed of light. And 2 lightning bolts hit the front and the back of the train, right when it gets to in front of the observer. And it keeps going. If you ask the observer at the platform, which one of those lightning bolts hit first, he'll say they hit at the same time. And the observer in the train will say the front hit first and then the last one hit second. So they disagree about simultaneity. And this was the idea behind the special theory of relativity, was that relativity is simultaneity. Turns out that's not right. Einstein's not right about that. You can tell, and here's a method for telling. You put a clock like the clock tower in Back to the Future, when the lightning bolt hits it, it stops the clock. You synchronize 2 clocks. You put them on the train, you run them past, the lightning bolts hit, and the guy on the platform was like, hit at the same time. And the guy on the train's like, they didn't hit at the same time, that one happened and this one happened. And they're like, let's go to the clocks. And you go find the clocks, and what do you find? Are the clocks stopped at the same time, at the same marker? Or did one of them stop later than the other?
I assume we have to guess at this.
You don't. Well, maybe you do. So in this case, you'll find that the clocks stopped on the same markers. So why are we blaming the guy in the in the train. He's wrong, right? The guy on the platform says they stopped at the same time. This one says that clock will have stopped first. This one will have stopped second. Then you ask him, well, did you guys observe anything else? The guy on the platform would be like, well, both lightning bolts were blue. And the guy in the train would be like, no, this one was bluish. This one was reddish. And you'll say, well, you're a good physicist. What do you know about that? He's like, maybe the second one, maybe it's a Doppler shift. Maybe this one happened and that one happened before and after. And I should have known that because I saw a Doppler shift. Now, here's the mind-blowing part about it. Here's the explanation of that. If the lightning bolts were moving with the train in the same frame of reference, he would see a shift in a certain way. And if they were moving, not moving according to the train, but stationary according to the observer, you might see different light behavior depending on what you think about how all that works. But at the end of the day, the bottom line is you can definitively say who was quote unquote right and who was not based on which of those clocks froze at what marker. Which is a problem with relativity that he eventually realized, sort of, mostly, I guess completely probably, by the time he wrote general relativity. So by the time he got around to general relativity, he realized there were some problems with special relativity.
So does more state changes imply more states?
Yes.
Okay. So when it's time to
It depends on your sampling rate, okay? So, like, all of this is interconnected. I hesitate to bring this open because you'd be like, Scott, we're trying to figure this out. Why are you bringing up this other thing? There's a very important philosophical point, by the way, that's killing us as a human race right now. Okay, here is a circle, and what is this distance right here? What number do we use to cover that distance? Pi. Okay, so you'll remember the circumference is 2 pi, or pi d, or something like that, right? Okay, so it's 2 pi is the distance around the circle compared to multiplied by the diameter or radius, depending on how you do it. Okay, how many points are on this circle for the top semicircle? And then how many points are there for the bottom half of the semicircle? So let me ask the question differently.
As many as you want.
As many as you want. So, but here's a different one then. Are the number of points, so this one's pi, we'll call it 1, we'll call this pi 2. Are the number of points in pi 1 the same as the number of points in pi 2?
Yeah, and it's the same as the number of points in pi 1 plus 2.
Right. So if you take kind of the Cantorian concept of infinities, you'll get wildly contradictory answers. So they'll say that for pi over 2, that there's the definition of whether the same number of points there, the infinity is the same size, is whether there exists a bijection between these two sets of points. And a bijection is a 1-for-1 relationship. For every one here, there's one over there. Bijection is a surjection. It's a 1-for-1 and onto. So there's a 1-for-1 correspondence in this set onto that set. So the number of points that lie right here is actually identical to the number of points that lie here, the entire distance, and is identical to the number of points that lie here. So this is a problem, right? Mathematicians just accept this. I do not. This is obviously nonsense. Okay, so they'll map a function as an example. The number of natural numbers, 1, 2, 3, 4, 5, all the way out to infinity. The cardinality of that set, the size of that set, is identical to the cardinality of the evens, 2, 4, 6, 8, 10, 12. Because you can write a function that maps the one to the other. And the function is f of x equals 2x. Right? So you can map 1 to 2, 2 to 4, 3 to 6, 4 to 8. And because I can 1-for-1 between the evens and the natural numbers, therefore they're the same size. I'm going to say we are missing the definition of numbers in there, and what all of this is forgetting is that the ordinals actually matter. In the correspondence of 1, 2, 3, 4, ... and 2, Scott, why is this not right? 2, 4, let's have a battery problem, 6, 8, that really what's happening here is that these are all ordinals. This is the first, this is the second, and this is the third. And that there is a bijection between the ordinals in any set that you that you make. And so I have an argument for why the continuum hypothesis is false, because I can create a bijection between the ordinals and any process that generates the reals, so that the cardinality of the ordinals and the cardinality of the reals are the same. Now, this sounds like a bunch of nonsense to you. Okay. But the point is this: until we agree on how you cut things up, you can't agree on how many states correspond. And so at a minimum, what I would say is, in order to avoid this confusion, whatever you do to the one is the rate that you have to do to the other. You got to be fair. You got to do the same process to both. So that was a lot of background on a simple question, but that if you're not thinking about that, you can tie yourself up in knots too. Okay. 2 minutes left. Yes, sir.
2 minutes left. Let me ask some questions that cannot be answered.
Very good. And before you start that, so we'll continue until we get the hook.
Yeah.
I will not be here next weekend. It sounds like a number of the other people won't be here next weekend. Solid Ground always goes without me. Feel free to come in and meet. But the following one, is the following one Thanksgiving weekend? No, it's the one before that. Okay. We will meet. I will be back in 2 weeks. You're welcome, invited, encouraged to meet here during that time and do so under a less dominating form of.
Weekend, the weekend after the Thursday.
Yeah, so we'll talk not next week, but the week after that about whether we want to go the following week as well.
Yeah.
Okay, back to your point.
So, skipping ahead quite substantially, if the purpose, and I'm just throwing this out, if the purpose of this universe is to decide where you want to be, or to make that, to figure out what kind of, do you want to accept God or not accept God?
Yeah.
So there's some inferences that, if thought is just change, if time is change, I can in my mind envision someone's mental process as occurring, if you just kind of took them outside of the physical universe. I could, as a brain in a vat, or as a person in Budo maybe, I could sit there and say, do I agree with God? Do I not agree with God? And I can kind of go through the mental processes, and I can run down to a conclusion, yes or no. Will that happen? Let's say I haven't made my decision in this lifetime. Let's say my life was cut short. I was killed very young.
Yeah.
Could you make the argument that for some kind of I don't want to say it theologically because we don't agree. Theologically, as good Christians, we don't necessarily, as non-Catholics, I should say, we don't believe in purgatory.
Right.
But the concept of a space where a mind could figure out that last, either if you just accelerated the clock, and who's to say that a nanosecond hasn't passed or 1,000 years haven't passed? If all you're talking about is mental states, what is the final mental state that this mind will end in, given certain known things?
Yes.
Could you make an argument for that? And the other question would be, what is the purpose of this life at that decision? What's the purpose of life at all?
Great questions. I will give you the teaser on it, and then in 2 weeks we'll meet and I'll give you the solution to it. Here's my teaser trailer. I think that the universe, this is changes running from left and right, okay? So I think that the initial state was God changeless, and I think he institutes a bunch of changes, and that the more people you have, the more potential changes you have. But eventually, and I don't know what the shape of the universe is, but let's say it's something like this, there's a reduction in people or changes or whatever, and eventually you end up with people making these, maybe there's another blow up as people make a huge set of thinking, and then eventually they come to a bunch of conclusions. And as you come to conclusions, you don't have to think about as much anymore, and I think that you end up with the end of the universe and the beginning of the universe in terms of number of changes that are happening in motion, that those are not identical because there are more things at this point than there were things at that point, but that the universe will be changeless at the end. Now, I'll go through why I think that's the case next time. But at least consider, if you're willing to do it, think about whether they're come back. You can disprove my hypothesis very simply. All you need is one property that time has that change does not have, and vice versa. If you've got one, that it cannot be expressed, one property of time that cannot be expressed in terms of causal change, then my argument falls apart completely. So, like, all you got to do is get one. Give me one, and you win. So I'll leave that out there for the next couple weeks. God be with you this time. See you next time. See you next in 2 weeks.